Alright, before we start, I'd like to remind you our test number 2 will be on next week. So we'll cover until chapter number 5, which is this last chapter lah. So when is your test 2? Huh? Your test 2 will be on 28th January next week lah. At 28th January on Friday. Okay? So it will cover chapter number I think chapter number alright, chapter number 3 and 3 until 5 lah. Let's look at the assessment number, chapter number 4 and chapter number 5. Right, means that hypothesis testing and bivariate analysis. So this is assessment number 2, which is your test number 2. Right, so make sure you study well on these two chapter, and jangan buat perangai copy daripada kawan-kawan, right? So this is your test, you need to do it by yourself, right? So I detect most of you, bukan some, most of you copying each other, right? So it's easy to detect, right? Because the same the wrong answer are same dengan semua orang, right? I think you buat dalam berkumpulan, right? So I cannot accept that behavior. Behavior is not acceptable. Then I will deduct another 5 mark for that behavior, right? So please do it by yourself and confident on your work. Jangan tiru, right? Kalau you tiru, kalau you betul, mungkin you dapat markah lah, right? But in future, you akan, bila you dapat kerja apa, you tak akan dapat gaji yang berkat lah. Rezeki tu depend on your own work. You nak berdiri di atas kaki you sendirilah. Jangan tiru orang. You tiru dengan buta tuli, right? Means that you sendiri yang tak bertanggungjawab atas rezeki yang you peroleh. Right, so you should appreciate the knowledge. You study by yourself, you gain by yourself, proud by your own work. Salah pun salah atas diri sendiri. Right. So now we continue our. So before I forgot, so you need to submit your project next week as well. Before your test, means that 27 January you should submit your project. Right. Itu saja. So project, I think I nak buat SPSS course introduction, but I don't think we have much time, right? Sebab hari tu I kena COVID, so I don't really expect that disease. So unexpected event lah, maksudnya. So I tak sempat lah nak bagi you free course on SPSS. So you should study by yourself. You can refer on my book. Last time I bagi satu buku kan, buku SPSS. You can refer on that book. You can also refer to many YouTube video on how to key in data in SPSS, how to do independent sample t-test in SPSS, and how to report the main point in project, how to report the result and interpret the result in dalam daripada SPSS. You cannot copy and paste your output from SPSS to your report. You need to rephrase, reconstruct your own table, right? So you need to refer to my book on SPSS, handbook of SPSS statistical analysis kan. Tengok nanti ada tunjuk dalam tu macam mana nak buat reporting for independent sample t-test, one sample t-test, one way ANOVA, regression analysis, how to do a reporting, right? That is the most important part, right? So now we move to chapter number 5. I think this is a very short chapter and very easy chapter to easy topic to understand lah. So basically we will study about bivariate analysis. So in bivariate analysis we're going to focus on two topics, which is a correlation analysis and simple linear regression. Right, very short topic. So correlation, look at number 1, correlation. What is a correlation analysis? Correlation is a statistical techniques used to measure the relationship and strength of the relationship between two variables. So you need to refresh back your knowledge on chapter number 1, right? So how many type of variable yang kita tahu? We have two type of variable, qualitative variable and quantitative variable. So under qualitative variable, commonly known as categorical data, right? Categorical variable. Quantitative variable also commonly known as a numerical variable, right? Under numerical variable or quantitative variable, you have two type of variable. Quantitative means that a discrete quantitative variable. Another one is continuous quantitative variable, right? So you need to understand this one. So we want to find the relationship between two variables, and these two variables commonly known as independent variable and dependent variable. But at this stage, we no need to emphasize independent and dependent variable, because at this stage correlation analysis, the dependent and independent variable is not really important, right? The important part is two variables. What are two variables? This is we're going to focus on Pearson product moment correlation coefficient, means that we're going to focus on quantitative variable or numerical variable, right? So we're going to focus on numerical variable, which is a quantitative variable, right? So at this method, we want to know what is the relationship between two quantitative variable, right? Whether it is a positive or relationship or negative relationship. Now, for example, let's say you have two variable such as study hours and CGPA, right? So let's say you study 10 hours, what is your CGPA? You want to know what is the relationship between CGPA and study hours. Is it a positive correlation or positive relationship, or negative relationship or negative correlation, right? So if these two variables are positive correlation or positive relationship, means that when you study more hours, then you will get more CGPA. If it's a negative relationship, means that if you study more hours, you will get low CGPA, right? That is the magnitude of the relationship that we want to know, right? So determine which variable, dependent variable and independent variable, is very important step in correlation analysis. This is false, not no. This is a second statement. The determining of variable, which variable is dependent and independent, is very important step in linear regression. Right? Ataupun kita kata regression analysis. Right? So in correlation analysis, doesn't care which one is independent or independent, right? So this doesn't if you want to determine dependent variable, independent variable, it should be very important in regression analysis, not in correlation analysis. But since we already touched about independent variable and dependent variable, let me elaborate to you what is independent variable and what is dependent variable. So dependent variable means that something you want to predict, right? Something you want to study, right? Independent variable is the variable that the variable that can cause dependent variable, that can affect the dependent variable. For example, let's say kita kata tadi CGPA and number of study hours, right? So CGPA is our main variable of interest. Means that we want to know what is the effect of CGPA if you study 10 hours per day, right? So study hour, a number of study hours does not depend on CGPA, but CGPA is depending on how many hours you study, right? So CGPA is your dependent variable, but number of study hour does not depend on CGPA. So since the variable is not depending to any variable, so this is what we call as independent variable, right? So means that the independent variable means that the variable does not depend on any variable, right? Dependent variable means that the variable that depend on others variable to make an effect, right? So that is dependent variable. So dependent variable will change when independent variable change, right? So it will completely depend on independent variable. So let's look at the example. Another example lah I boleh bagi kan, contoh yang mudah. Let's say risk of having heart disease and number of cigarette smoke per day, right? So risk of heart disease depend on how many cigarette you smoke per day. So if you smoke 20 cigarette per day, the risk of getting heart disease is increased, right? Contoh macam tu kan. So that is another example for dependent and independent variable. So let's look at another example here. So in many business situations, manager often want to seek relationship between sales and profit. So we want to know what is the relationship of sales and profit. What is the relationship between advertising expenditure and sales? The more you invest on advertising expenditure, so is it affecting our sales to be increased or decrease? So kita nak tahu macam tu. So sama ada kita berbaloi tak invest banyak dalam advertising expenditure, right? So in this example, you can say that advertising expenditure and sales. So sales is depending on how many amount of money that you spend on advertising expenditure. So sales is a dependent variable, advertising expenditure is independent variable, right? So another statement dekat sini. Similarly, if you have a production cost and production unit, then we will say that production cost will depend on the production unit. So if the production unit increase, the production cost will decrease. So they will have a negative correlation usually, yeah. So the method to determine correlation, right? So we have three methods here. First is by using a scatter diagram. So scatter diagram is a graphical presentation. So usually we will have two axes. So this is a y-axis and this is a x-axis. So it will show us the scattered point, right, to show the magnitude of the two variable. So let's say this one is production cost, production unit, right? So selalunya dia akan decrease lah. So dia akan bentuk macam ni. Sama ada dia akan bentuk menaik ataupun menurun. So dia ada dua pattern, right? Macam ni, right? So this is another example of negative correlation. When the production unit increase, right, the production cost will decrease. For example, right? So this is example of scatter diagram. Scatter diagram is a graphical presentation to show the relationship between two variables. So in this subject, we are focusing on linear relationship, right? We are not focusing on a quadratic relationship or any pattern of relationship. We just focus on linear relationship because we are looking into linear regression next topic. So another method that we can that can be used to determine the correlation is Pearson product moment correlation coefficient of correlation. The symbol is small letter r, right? So this is for quantitative variable. So they will give you the value of r, where the r it should be less than, the value of r is between 0 and 1. So the higher value of r means that approaching to 1 means that it having a strong relationship. When the value of r is towards 0, right, it means that you having a weak relationship or no relationship at all, right? So now we have another method which is Spearman rank coefficient of correlation. This is, the symbol should be rho, right? This is a symbol, bukan RS, rho, right? This is a common symbol for a Spearman rank coefficient of correlation. So this is mainly designed for qualitative and quantitative variable. But in our topic, our subject, we are focusing more on quantitative variable. So we are going to stop at Pearson product moment coefficient of correlation and scatter diagram. For Spearman rank, we will not cover in this topic. But there is a method, you need to aware, there is a method to, another method to determine the correlation, right? Such as a Spearman rank correlation, coefficient of correlation, or Kendall tau. There are more methods. Let's say in machine learning, we have you learned machine learning classifier? Ada belajar lah. Alright, you have belajar KNN, K nearest neighbor. Pernah belajar K nearest neighbor? Right? So dalam K nearest neighbor, we have many distance such as Euclidean distance. We have block distance. Banyak lah distance ni semua adalah semua benda yang sama untuk measure correlation lah. Right? So most of the method in machine learning ada juga menggunakan distance yang berbeza. So now, this is when you use Pearson product moment coefficient of correlation, so you will get a strength of correlation, right? So the difference between scatter diagram and Pearson product moment coefficient of correlation, scatter diagram does not give us the strength of correlation, right? It just gives us the magnitude or the direction of the correlation, whether it's a positive correlation or negative correlation or no correlation at all. But for Pearson product moment coefficient of correlation, it will give us the value of R. The value of R, macam tadi I cakap, is between 0 and 1. So now what is this section for R value? So this one, kena nampak dekat sini, ni dia bagi sedikit berbeza lah, from negative 1 to 1, because if you still remember, in scatter diagram, kita tengok tadi, I terangkan tadi, we're going to have a positive correlation or negative correlation. But basically, the value should describe from 0 to 1, right? So 0 to 1 is indicating how strong the relationship. If you have a negative 0.1 to negative 1 is also between 0 and 1 juga, benda sama lah, tapi but we impose a negative value, negative signs, right? So it's still indicating the same thing, right? But in this one, dia sebelah negative part lah, misalnya negative correlation. So now, when interpreting the value of correlation, the strength and direction, positive or negative, or correlation must be stated. Right? So in this table, you can see that when R is equal to 1, means that it's a perfect correlation. So in this stage, rarely we get the perfect correlation lah. So from 0.8 to 0.99 is indicating a strong correlation. So this one I tunjuk dia punya strength saja tau. Let's say you got here negative 0.81. So it means that it's a strong negative correlation. If you got 0.81 only without negative sign, it's a strong positive correlation. So you need to remember the sign. The value are still same, indicating strong correlation. So when you have the value from 0.5 until 0.79 is indicating a moderate correlation. Until 0.49, this 0 is not inclusive. It's a weak correlation. When R is equal to 0, it means that there are no linear correlation. Right? So that is the strength of correlation. So now, scatter diagram, tadi I dah tunjuk tadi. Right, kita can skip this one, terus ke sini. Page number 162. So, this is the pattern that can be in scatter diagram, right? So if you got this pattern, right, it means that dia menaik kan, from left to right, dia increase from left to right, so means that it's having a positive correlation. Kalau dia dekat saja semua ni dalam satu line macam ni, right? So semua ni dekat-dekat, so maksudnya dia strong positive correlation, right? So kalau kita tengok dekat sini, dia macam jauh-jauh sikit dia punya distribution dia. Tapi dia punya pattern ada juga. Nampak pattern dia naik kan? So this is a weak positive correlation. Same goes to negative correlation lah. So kalau dia menurun, right, but the distribution of observed value ni dekat-dekat. So this is a strong negative correlation. So sama juga dekat sini, dia menurun. Nampak pattern dia menurun. But the observed value dekat sini dia macam jauh-jauh sikit. So this is a weak negative correlation. Right? So now, let's look at this one. So if you have observed data and you tak nampak dia punya pattern, sama ada naik ke ataupun menurun. Right? You tak nampak pattern dia ataupun dia dalam bentuk satu bulatan. So dia dalam bentuk bulatan macam ni. Right? Satu ni lah. Dia tak nampak pattern. No pattern can be seen. So this is indicating no correlation at all. So kalau you nampak pattern juga kat sini, you nampak pattern first half is menaik, second half is menurun. Right? So this data is having a correlation juga. Ada correlation. But it's not a linear correlation. It's a quadratic correlation, right? So that's why we are focusing on linear correlation only. We are not focusing on quadratic correlation, right? So this is an example of perfect correlation. So di dalam bentuk satu line saja, right? So this is a rare situation lah. Kalau ada pun means we can suspect bias, very high bias on the data, right? Because it's a very rare event to get a perfect relationship. So kalau dia menurun, benda yang sama jugalah. Kalau menurun, perfect negative correlation, dia menurun macam tu. Dia dalam satu straight line. Right? So let's look at the computation section for Pearson product moment coefficient of correlation. Right? So as I said just now, Pearson product moment coefficient of correlation, it will give us the value of R, and the value of R is indicating how strong the relationship, whether it is a strong relationship, moderate, or weak, right? Or no correlation at all. So now, Pearson product moment coefficient of correlation measure relationship between two variables and also strength and of the degree or the degree of correlation. So the strength of correlation can be either perfectly correlated, strong correlated, moderately correlated, weak correlated, or no correlated at all. So this is the formula for R, Pearson product moment coefficient of correlation, summation of xy minus summation of x multiplied with summation of y divided by n. So this is the first one. So this one we call as SXY. Right? So divide by the square root. You nampak kat sini? This is the square root. Dia square root kat sini. Kat bawah. Divide by square root of summation of x square minus summation of x and u square divided by n, multiply with summation of y squared minus summation of y minus summation of y then u square divided by n. So this first part is called as, the first part is called as xxx, then yy. Sum of square xy, sum of square xx, sum of square yy. Right? So you need to remember summation of y squared is not equal to summation of y and then u squared. It's the same function as summation of xy is also not equal to summation of y, summation of x multiplied with summation of y. It's a different value. Right? And same goes to x lah. Benda yang sama jugalah. Tak sama. Right. So computational ni nanti kita akan fokus kepada Casio 570ES, right? For MS you need to study by yourself. Ada juga ni dia ada bagi dia punya jalan kira macam mana nak buat untuk MX. So MX dekat sini lah. Right? So you boleh tengok sendiri. So if you still use the old calculator, so you boleh pakai MX kat sini. Right? So now let's look at example number 1. Right? So example number 1, a marketing officer in the company wants to know the relationship between annual advertising expenditure and annual sales of the company. So we need to know annual sales is depending on annual advertising expenditure. When you invest more money on advertising expenditure, it is expecting your sales to be increased as well, right? So for the study, he collected data on advertising expenditure and annual sales of the company for last 8 years. So this is by year lah. This is 1, 2, 3, 4, 5, 6, 7, 8. So this is annual sales, annual advertising expenditure. So now, tadi ada cakap in correlation analysis, we doesn't care X and Y, which is independent variable and dependent variable. But it is a best practice juga untuk to identify which one is dependent variable and which one is independent variable, right? Because usually in final exam, the question will be continued to simple linear regression as well, right? So if you fail to identify which variable is dependent and which variable is independent, you might have a correct answer on Pearson product moment coefficient, but you will having a wrong answer on simple linear regression, right? Kalau you salah identify, kalau you betul identify, then should be no problem, right? So now this one should be Y and this one should be X. Means that X is an independent variable, Y is independent variable. Means that kita kena tengok betul-betul soalan apa dia punya variable tu. You need to ask about yourself, which one is dependent variable? Sales depend on expenditure or expenditure depend on sales, right? So you need to having a logic thinking as well lah, right? So now, since we already know this one X and Y, so and we know that the formula of R is equal to summation of xy minus summation of x minus summation of y divided by n, and everything divided by square root of, the first part is about x square minus summation of x square divided by n, and second part is about y, summation of y squared minus summation of y squared divided by n, right? So this is a formula. We want to input the data and get this value, right? Where is it? So now, first step, bila nampak calculator first step we need to click on mode. Tapi sebelum you click on mode, if you have done previous work kan, dalam final exam kan, you akan banyak guna calculator kan, you need to save the memory kan. So you need to go to click on shift and click on 9 and clear all memory. 3 sama dengan AC, right? Shift 9, choose 3 to clear all memory and click equal to yes and press AC key, right? So now you need to click on mode and find statistics. Find statistics number 3, and previously we are using 1 minus variance, right? So now we are going to use A plus BX. A plus BX, which is number 2, you will get this column. So now you input the data lah. So X masuk dalam kolom X, jangan tersilap masuk. So this is 2, 1, 4, 3, 2, 4, 5, and 3. So all together we're going to have 8 observation lah. So then we input for Y 5, 3, 6, 5, 4, 7, 8, 6, and we can always recheck our input, right? So make sure your input are correctly input into your calculator. Alright, so now tekan on, tekan AC pun boleh, right? Since we want this value, right? Summation of xy, you just click on shift and 1, right? Sekali lagi shift 1 and tekan 3 untuk sum. Now we will have the value. So xy yang pertama ni ada number 5. So tekan number 5 lah. So tekan sama dengan 146. See, you can get the value kan, 146. Right, so this is how we got the value lah. Benda yang sama, you tekan balik. So summation of summation of x square, number 1. So you will get 84. Should be 84 here. Right, summation of y squared, number 3. So 260. Dah ada kat sini. So and so on lah. You boleh kira kan. You boleh tekan balik banyak-banyak. Suka hati you. So my advice is you stick on the original formula. Right, original formula. Right, so you just input the value dalam original formula. So this one I letak another color. So let's say summation of xy is 146 minus summation of x is 24 multiply with 44 divide ini divide by n, right? Divide by 8. Right, this is 44. And everything divided by, don't forget the symbol of set, right? And then you do for the first part, which is summation of x squared is 84 minus 24 squared divided by 8. Then you multiply with summation of y squared, 260 minus, this is 44 divided by 8. 44 squared. So I don't expect you to calculate it manually, okay? So you just see the value in the formula, key in the value or plug in the value into the formula. Now you tekan shift 1, right? Once you already key in the value on the formula, tekan shift 1 and tekan number 5 for regression, number 5. So then you need to find number 3 for R. Tekan 3 untuk R equal to 0.9525. 9526. 0.9526. So 0.9526 is a positive value, right? It's a positive value. We're going to interpret as strong positive correlation between annual sales and annual expenditure. Advertising expenditure. Advertising expenditure, right? So the interpretation is there are strong positive correlation between annual sales and annual advertising expenditure. Right, so that's how we interpret lah. Dia kat sini dia bagi strong relationship kan. Kita letak strong correlation, benda yang sama. Okay. So you can do it the example number 2. Do it by yourself, benda yang sama. But before that, we can look at the example. Dia kata benda yang sama juga. Dia bagi 8 families, right? So they give us annual income and food expenditure. Food expenditure depend on annual income or annual income depend on food expenditure? Which one? Which one? Ni kalau you salah define ni, you salah dekat correlation je. Kalau usually soalannya dia akan continue to linear regression. Right? So kalau you salah dekat sini, correlation you betul, linear regression you salah. So in this example, food expenditure depend on annual income lah. Food expenditure is dependent variable. Annual income is independent variable. Right? So you can do it by yourself. Now let's look at a simple linear regression. So in simple linear regression, right, the basic concept, what can I tell you? Remember scatter diagram, right? Scatter diagram yang kita tengok tadi. Tapi kita tak buat pun lagi, Nanti kita akan tunjuk dalam menggunakan SPSS, right? Sabar sekejap. Right. So let's say I have right. So I have this data, right? So this is the data. I plot into a scatter diagram, two continuous data. So we know that from a scatter diagram, we have a positive correlation, right? Because the direction is increasing from left to right, right? So in correlation, we just know the relationship only, right? So let's say kita letak this example as a study, CGPA lah, CGPA and study hour, right? So as the study hours increase, CGPA also increase, right? So the maximum should be 4 lah kat sini, right? From 0 to 4. This is, let's say, study hour 1 until 24, right? 24 jam tak tidur langsung kan. So for this subject is 140 hours kan. 140 hours. Sorry. This subject is berapa 40 multiply with 3, 120 hours, right? You need to study by yourself 120 hours kan. Remember in the first class I already explained this one. So let's say 120 hours lah, right? So if you study 120 hours in this subject for the whole semester, then the study says that you will get 4 flat, right? 4.0 means A lah, A or A plus, right? So by using scatter diagram, we can only know the relationship. But if you want to predict, right? If you want to predict, let's say Ahmad, you know that from this data, you collected 30 students. Let's say a new student coming. A new student coming, let's say Ahmad. Ahmad study, Ahmad is not part of this data though. Ahmad is another person from another class. Right, Ahmad come in, kita nak tengok Ahmad study 80 hours for the whole semester, 80 hours for this subject. So what will be the CGPA, expected or predicted CGPA for Ahmad? Right. So linear regression, apa yang dia buat adalah dia nak cuba mencari satu line di tengah-tengah yang best fitted. Right. So line ni dinamakan dia ada macam-macam method, but we are focusing on least square method, right? So this is based on least square method. So dia akan letak satu line yang predict well for this data, and this line is unbiased line, right? Unbiased estimate. Yeah, unbiased estimate doesn't mean it's a good estimate, right? But it's unbiased estimate, right? So distance dekat sini. So this distance antara observed value and predicted value, right? This is a predicted value warna hijau ni kan. Observed value adalah warna pink ni. So the distance is we call as error. So distance semua ni kita akan kira dia punya error lah, and then kita akan ambil sum of square of error. So that's why we will get a sum of square error kat sini lah. So the error for least square method usually it depend on data lah. Usually not very minimum lah, but we can ensure this is an unbiased line, right? I can prove unbiased line for least square, right? So this is what we linear regression try to do, right? Basically, so linear regression, the equation for simple linear regression, remember this is a simple linear regression where it consists only one dependent, it consists of one dependent variable, and another one independent variable. So dia ada dua variable saja. One dependent variable and one independent variable. So now, let's look at regression analysis is a statistical techniques estimate the best fitted line to show the relationship between dependent and independent variable. This fitted line is also known as regression line or regression equation. So this equation, this line is y equal to a plus bx. Ataupun dalam some books we will say in statistical books beta naught plus beta 1 x1. Right. So this is the equation beta naught plus beta 1 x1, or in simple in this subject kita pakai a plus bx lah. If you still remember, this is closely related to y equal to mx plus c. Right. You belajar dalam SPM dulu kan. So m is a slope, so b is your slope. C is intercept, so a is your intercept. This is a y-intercept. So y-intercept here, so this is a, the value of a, and the slope is your b. Right? The distance between the difference of these 2 points we call b, slope. Right? So x is your independent variable as well. So now I hope you understand. Right? So this is about regression analysis lah, and yang dia buat ni kan. So they try to find the best fitted line, right? The best fitted line to the whole data is we can use a least square method lah. So this is unbiased line. So now let's look at how to calculate the value of a and b by using least square method, right? So you are using least square method. There are many methods out there, such as orthogonal method and so on, right? So b is equal to, so kita balik kepada asal formula. So y is equal to a plus bx. So firstly, to get a value, we need to calculate b value first. So b is equal to summation of xy minus summation of x multiplied with summation of y divided by n, everything divided by summation of x square minus summation of x, and then you square divided by n. If you notice, the formula are mostly equivalence to correlation punya formula, right? Cuma dekat sini kita tak multiply with a summation of a sum of square y, right? So benda yang sama kan? So from here you will calculate the value of a. So a is equal to x bar, y bar minus plus or minus, right? Plus or minus depending on the value of b. Plus minus b x bar. So remember, y bar is a summation of y divided by n plus minus b summation of x divided by n, right? It's not minus b x bar, it's a plus minus, right? It depending on the value of b. Okay, so interpretation value of a and b, right? So the meaning a is when x is equal to 0, y is equal to a. So for b, for every 1 unit increase in x, y will increase as well. If b positive lah. If B is negative, 1 unit increase in X, Y will decrease by B unit. Right? For example, dekat sini, if B is equal to 32, means that for every unit increase in X, Y will increase by 32 units. If B is equal to negative 32, for every unit increase in X, Y will decrease by 32 unit. Right? Boleh So, dia another value yang kita boleh dapat dalam correlation coefficient, right, dalam linear regression. And selalu kita kena report adalah coefficient of determination, which is R squared. Right, R squared is a statistic which indicate the accuracy of prediction. Right, no, this is not accuracy of prediction. Right, it's not accuracy of prediction. It explains how many percentage of independent variable explain to Y. Means that, let's say we have a number of study hours, right? Sorry, number of study hours, and number of study hours and CGPA. So we want to know how many percent number of study hours contribute to CGPA. Let's say R squared tadi kita dapat number of study hours. Tadi tak dapat, kita bukan buat study hours kan, kita buat sales and expenditure. Right, we get 0.9256 kan. So 0.9256 is R value, 0.9526, right? So this is R value for advertising and sales, right? So we want to know how many percent that advertising expenditure contribute to sales. You faham tak? Kita hanya measure satu variable dekat sini. There might be others variable yang tak dimasuk dalam model ni, yang kita tak kira, tak consider, tapi dia contribute juga kepada sales. Contoh macam marketing benda yang lain lah, ataupun kenalan ke, ataupun tiba-tiba dia viral berkenaan dengan apa ke, kita tak tahulah, right? Atau produk tu tiba-tiba jadi demand full, right, due to COVID ke, we don't know, right? So 0.95826, kalau nak cari coefficient of determination, we need to square the value of R. So R square is equal to 0.9526 square. So we will get 0.9526 square should be 0.90 kan. So it should be expressed in term of percentage. So you need to multiply with 100%, should be equal to 90.74%, right? R squared should be expressed in term of percentage lah. So we know that 90%. So 90%, this is a 90%. So 90.74% of the variation, the total of the total variation in annual sales is explained by annual advertising expenditure, right? So we know that from here 90% of the total variation in annual sales, right, explained by annual advertising expenditure. We know that annual advertising expenditure contribute 90% on annual sales. Lagi 10% mana lebih? The balance here should be berapa? 1 minus answer should be 0.09. This will be 9.2%. For example, not accurate, but 9.25%. 9.25% of the total variation for of annual sales came from others factor that not included in the model. Right? Maksudnya ada faktor lain yang kita tak consider dalam model ni juga contribute kepada annual sales. Maksudnya mungkin dia ada CEO yang bagus, right? Orang minat dengan CEO tu, nampak ini dia invest dalam sales, right? Ataupun barang goods dia diperlukan pada waktu dan ketika itu, right? So dia ada juga contribution yang lain, right? So that is a coefficient of determination. So now let's look at example number 3. So example number 3 ni dah ada value kan? So can we skip this one and focus on example number 4? Ini you boleh tengok sendirilah. Right, we look into example number 4. Tapi tak short juga sebab dia ada 2 example je. We look at example number 3 lah. Example number 4 you can do it by yourself. So benda yang sama. Ni example yang saya bagi tadi kan. Nampak tak ada study hours. So a lecturer want to know the relationship between number of study hours in a week and GPA obtained by 10 students selected randomly in the class. So we have 10 students, number of study hours and GPA. Right, maybe number of study hours per week in a week, right? So we need to firstly we need to determine which variable is dependent and which variable is independent, and that is the most crucial step, the first step that we need to take. So number of study hours depend on GPA, GPA depend on number of study hours. GPA depend on number of study hours. GPA is Y, number of study hours is X. So then, dekat sini kita dah state number 1. Number 2, we want to find a Pearson product moment correlation coefficient. So we need to look at the formula, summation of XY minus summation of X, Y, and everything divided by, don't forget the square root. The first part should be X, square, X, and then square N. Then multiply with summation of Y squared, summation of Y, and then you square divided by N. So this is the value that we want. So begin to key into the data. So mode 3 stat and choose A plus BX, number 2. So do not mix up dia punya value. Right, kalau you salah dekat sini, yang bawah semua akan salah. Maybe you will write on Pearson, tapi dekat bawah linear regression you akan salah. So 9 should 7, 10, 6, 7, 8, 12, oops, 12. And then 4, 5, 6. So ada 10 kan. So the next one is 3.2. You kena masukkan betul-betul lah. Salah masuk kalau you masuk yang 3.2 ni letak kat 10. Tu you suka hati you nak letak macam mana kan. Itu salah lah. You akan dapat wrong result. 3.15, 2.84, 2.98, 3.05, 3.48, 2.01, and 2.28. The last one should be 2.9. Right? So semua ada 10 lah. So the next step is you need to find the value of all the value that required lah. Summation of X, Y, summation of x, summation of y, summation of x squared, summation of x, y squared. Right, we already know n is equal to 10 kan. So you cari semua value tu, and then you plug in the value into the formula, right? Kalau you tak plug in the value into formula, you will not get any marks, right? So you need to plug in the value into formula, then you tekan calculator untuk dapatkan value. So this is 222 minus 74 multiply with 28.89 divided by 10. Then everything divided by square root. Is the first one is 600 minus 74 squared divided by 10. The second one multiply 85.1699 minus 28.29 divided by square this one, square divided by 10. Right. So then you tekan calculator, shift 1 5. Cari 3 untuk R. So you will get 0.8897. 0.8897. So dekat sini dia bundarkan kepada 2 kan. 2 decimal point should be 0.89. So but you can leave it as it is 4 decimal point. So we can make it standard 4 decimal point as our measurement lah. So next step, find the regression equation for GPA based on the number of study hours. So y equal to a plus bx, where y is your GPA, x is your number of study hours. So b is equal to summation of xy minus summation of x multiply with summation of y divided by n. Everything divided by for x kan, summation of x square minus summation of x and then the square divided by n. So remember dekat sini, for this question, if you wrongly identify the independent variable and independent variable, you will get a wrong result. Wrong result for this, wrong result for this. For this one, it might be true lah. Right, sebab ini datang daripada atas. So you just plug in the value here. So summation of xy should be 222.2 minus 74 multiply with 28.89 divided by 10. Always shows value that you already input into the calculator and into the formula. So 600 minus 74 squared over 10. So this one no square root . So dekat sini you tak payah kira, no need to calculate, right? You don't need to calculate, you just tekan shift 1, tekan 5 untuk regression. Now you can see ada B dekat sini, 2 kan? Ada 2 B. So tekan B sama dengan, so you will get 0.16. 0.16 berapa? 16006. So this is a positive value, right? Positive value. So then kita guna satu lagi A. A is equal to y bar minus plus minus is depending on B value kan? B x bar. Right, which is equal to summation of y divided by n plus minus b summation of x divided by n. So this one should be summation of y sama dengan y apa? Oops. Y sama dengan 28.89 divided by 10 plus 0.1606, which is, this is the value of B, right? Multiply with 74 divided by 10. Tak payah kira, just tekan shift 1 5. So you nampak the value of A, which is 1. It should be 1.70, 1.7007. Is it? 007, 008. Ya, kita bundarkan 4 decimal point, 008. So then, lepas you dapat value of A, B dengan A, right? Don't ever forget to plug in into the formula, into the equation. Kalau you biar macam ni, you hilang satu markah untuk equation. This is quite big marks. Ini satu markah saja. Satu markah banyak. Sebab dalam ni ada setengah markah, setengah markah, setengah markah, setengah markah. Right. So, then, so let's say I use this color. So, A sama dengan 1.7 kan. So, what we need to do is Y hat. It's starting with Y hat. Sebab ini adalah predicted equation. Y hat equal to 1.7008 plus, so this is a positive value kan, 0.1606x. Boleh Okay. Right, very easy. So now, what does it mean by this formula ni? This is the equation that we got. So let's say A ni maksudnya A is 1.7008, right? Yang kita dapat kan, this is 8. Indicate that when the number of study hours 0, GPA is 1.70 lah. So when X equal to 0, Y should be equal to 1.70. This is a CGPA. Sebab CGPA 2 decimal point kan? Remember? It cannot be 1.7006. It should be 1.7. I directly interpret lah. Ikut dia punya situation. Right? So, for B is your slope. So since B is equal to 0.1606, for every 1 unit or 1 hour increase in Y, increase in X, 1 hour increase in X, the GPA will increase 0.1606. Right? So now, let's say you're not sure which one is X and which one is Y. Betul-betul confused, tak tahu. Ini Y ke ini X? Right? What we can do? First, think logically. So, if you think logically pun, you tak boleh fikir juga. So, you tengok soalan yang ada estimate GPA. Last question. Kalau dia kata estimate GPA, so you know that this is your Y lah. Right? If obtained by Lisa by study she studies 11 hour per week. So this is X. You already know automatically from the last question. So if you have this question lah, kalau you don't have this question, then susah jugalah. Right? You need to think logically juga. So think logically for which one is X and Y, and confirm it by the last question. Right? Boleh So now kita tengok dekat sini, calculate the value of coefficient of determination. Coefficient of determination is R squared. It's capital R squared. Explain its meaning. So our R is equal to berapa? 0.89. So the R squared should be 79.21. It means that the total variation, so So 79.21% of the total variation in GPA, right, is explained. So dia punya ni sama je. Explained by the number of study hours. Right. So dia nak tambah lagi, while the balance are explained by others factor that not included into the model. Boleh very simple. Right. So this is a very simple topic. So now estimate the GPA obtained by Lisa if she studies 11 hours per week. Right. So y hat is equal to kita punya equation tadi 1.7008 plus 0.1606 x, right? X. So we know that study hours is our x, right? So you just input the value lah, 1.7008 plus 0.1606 multiply with 11. So you just calculate the value, right? Calculate the value. 0.1606 multiply with 11 plus 1.7008 should be 3.4674. 3.4674 sebab we need to make it logically lah. 3.47 equivalent to 3.47. Yeah. Okay. Any questions so far?
Sir.
Yep.
Example 2 just now, page 165. You said that
165. Okay.
You said that food expenditure depend on annual income.
Yeah.
Bukan ke annual income depend on food expenditure?
Ya ke? Food expenditure, berapa banyak you
Depend
nak
on-
belanja untuk makan, depend on annual income lah. Berapa banyak duit yang you ada. Kan? Kalau duit yang you ada depend on ni tak logik juga. Tak. So then you need to think logically lah. Sometimes it might be confused, right? So
So boleh jadi ke kalau annual income tu dia jadi Y? Kalau kotak dia actually memang XY lah.
yeah. Kalau dia takkan bagi you direct XY, dia akan bagi macam ni lah selalunya. So kalau you tersalah letak kan, let's say you letak annual income as Y and food expenditure as X, right? So you might have a correct answer. You definitely you're going to get a wrong answer on this A lah, okay? Tapi on product moment correlation ni, you will get the correct answer lah. So nampak dekat sini. Alright. Important part dekat sini dengan sini. Right. So definitely you will get this one half marks. This one half marks. This one wrong. You hilang 2 markah kat sini. Dekat sini you will get this one half. Yeah. So 1.5 atas. This one you akan dapat betul juga. Sebab I takkan refer kat sini lah. Kalau I straight, I bagi salah lah kan. But you will get the same answer lah. You got this one also. correct answer. Tapi you hanya hilang 2 markah dekat sini. Yang lain semua you betul. Tapi bila you pergi ke simple linear regression, dekat sini semua salah. Ni semua salah. Salah. This one correct. This one interpretation ni semua salah. This one also wrong. So kesian lah. Susah lah. Rugilah kan. So make sure you selalunya tips dia macam tu lah. You need to think logically. Right. First, think logically. Second is confirm your X and Y tu dekat soalan yang belakang sekali ni. Right, estimate GPA. So you know lah, you want to estimate. Always when we want to estimate, selalunya kita akan estimate Y. Kita tak akan estimate X. It's against the nature. Right. So soalan dia tak akan tanya estimate X. Against the nature. So kita akan tanya estimate Y. So you know already Y adalah GPA kat sini. This is one tips lah. Okay. Okay, boleh fikir ini. Age and number of absent days. Which one is Y? Which one is X? Number of absent days depend on age ke? Age depend on number of absent days. So dia kata, tapi sebelum tu kita tengok dulu soalan dia. Jangan suka-suka hati jawab terus kan. A supervisor of a factory produce electrical appliance finds that 3 exists relationship between age of workers and the number of absent days. Then he collect the following data from 10 production operators. So dia tak membantu sangat lah dia punya soalan tu, dia punya statement tu. So kat bawah ni nampak ni, okay. So let's say we cannot decide, but I'm thinking, first guess is number of absent days depend on age, not age depend on number of absent days. But age is totally independent, right? So to confirm this thought, so I tengok dekat sini. So Haris is 28 years old. What will be the expect number of absent days? So kita nak predict number of absent days. So number of absent days is your Y, age is your independent variable. So easy to detect. Right? So alright. Now let's look at kita rehat dulu 5 minit. I nak tunjuk SPSS, then we will end our ni lah. Right. Lima minit So let's continue on SPSS. So let's look at this data. Example number 5 ni. An observation was carried out to determine the relationship between age of a chef and the time in minutes needed to prepare a dish. So the table below shows the data recorded by 8 randomly. Right, okay. Randomly recorded by 8 randomly selected chef lah. So now kita ada dua variable kat ni, age and time. Right, so in SPSS we need to go to variable view. Right, dia ada dua tab data view and variable view. Right, so we create the variable first. First variable is age. Second variable is time. Right, so these two variable are numerical variable. Right, so decimal, there are no decimal point in this variable. Kita tengok example ni. Right, nampak tak? No decimal point, so decimal point should be 0, 0. So this is age. Label kita letak age in years. Right, another one is time in minutes. Right, so then dekat hujung ni Dekat hujung ni kita letak measures, scale, measures, scale. Untuk dua-dua lah. Right? So ini adalah how we define the value. Right? Boleh ikut? So now, next kita tengok, kita tengok data view. So data view kita masukkan data lah 23, 45, 34, 50, 44, 29, 36, 52. Right, so we have 8 data, right? So next time is 63, 52, 55, 54, 50, 60, 57 and 50. Right, so now first step that we want to do is we want to get the value of coefficient of correlation. Right, so there are two methods now. In newer SPSS, I'm using SPSS version 28, right? This is 28, version 28, 28 dekat sini today. So the traditional method, if you want to have correlation structure saja, so you go to analyze and stop at correlate, cari bivariate, and then you akan nampak dua table, dua column kat sini. Age, this is all the variables in your data set, and this is the variable to be analyzed. So you select these two variable, include into variables column. And then dekat sini kita ada correlation coefficient dekat sini. You just, by default is a Pearson. You just leave it as by default. And test of significance, we're going to test at two tail. Right, and then so we don't want diagonal actually. Tapi tak apa, dia dah bubuh kan. So option dekat sini, if you want mean and standard deviation, you can click on mean and standard deviation as well. But I think a confident interval, yes. Confident interval, if you want 95% confident interval, you can click on estimate 95% confident interval. But I don't think I want this for at the moment, so I just enable this one. And then I click OK. So I tunggu dia punya result lah. Where is the result? Okay, now they give us the result. So the result dia bagi dekat sini bentuk sama dengan ni tak? Sama je kan? Sama, right? Okay, then kalau sama I boleh explain kat sini saja. So dekat sini, so this is the SPSS result as our output. So the first one, Pearson correlation. This is the R value. Dia sama. Dia kat sini kita measure dua variable saja kan, age and time. Right? So age and time dekat sini. So this is Pearson coefficient. This is R value for age and time. Right? So kita nampak dekat sini is negative 0.901. Right, so means that if we having a strongly negative correlation between time and age and time, right? So this is a significant value, which is p value. P value is 0.02. So if you still remember on last chapter, hypothesis testing, the hypothesis for correlation analysis is there are no correlation between time and age. This is for null hypothesis. For alternative hypothesis, there is this is a correlation between time and age. So since the p value is less than 0.05, we're going to accept null alternative hypothesis. So we conclude that there is a correlation between time and age. So the strength of correlation is 0.901, which is negative 0.901. So we can conclude that there is a strong negative correlation between time and age. So this is how we interpret and we understand the result output from SPSS. So now when you want to do a regression, right? So kita tak pergi, tadi kita buat analyze, correlate and click on bivariate, right? To get the correlation value, right? If you want to have a linear regression result, instead of going to correlate, we move to regression. Regression and we select linear, right? We select linear. So analyze, regression, linear. So we click on linear. So kita nampak dekat sini dia ada bagi time and age, right? So dekat sini apa dia punya time and age? Which one is so time depend on age, right? Time depend on age, bukan age depend on time. So time is your dependent variable, right? So time should be dependent variable, age should be independent variable, right? So this is how we do it. Independent variable should be on age, dependent variable to be on time. So then kita pergi ke statistic. By default, regression coefficient is estimate. And we need confidence interval as well. We need confidence interval and kita kena letak lah, by default dia tak letak kan, dia tak tick. So you need to tick confidence interval, make sure 95% confidence interval and model fit, that's it. Cukup ah. Collinearity diagnostic tak perlu sebab kita buat single variable. So click continue and then plot ni it become too complicated when we want to check the assumption, but at your level I think you don't need to check assumption, right? So I think that's all and click OK. So they will give us dekat sini ya. Kalau sini I padam tadi, yang ni correlation tadi I tutup So ini tinggal regression dekat sini. So regression dekat sini dia bagi tahu ada 4 table. 4 tables. The first table is variable entered or removed, model summary, ANOVA and coefficient. Right. The first table indicate how many variable, independent variable included in the model. So the dependent variable is time, the independent variable is age. So the method is enter lah. So the second table is about summary, model summary. R is 0.01. 9.01. So R dekat sini sepatutnya sama dengan atas ni. Nampak R dekat sini dan table number 3 is equal to the value of R, the Pearson correlation dekat correlation. But the only difference is dekat correlation table ni dia ada negative sign, right, which is a negative correlation. But in R, model summary ni dia tak bagi tu negative. Right, we cannot assume this is the actual R, right? So it's actually absolute R. Maksudnya dia dah ambil positive side, dia dah bagi absolute. So this is the R squared 0.811, means that the square, the value of 0.901 square should be equal to 0.811. Benda yang sama lah, right? So bawah ni dia ada bagi dekat kita ANOVA. ANOVA means that the model of fitness, kita boleh skip this one, right? Kita boleh padam, tinggal 3 ni saja, right? Tadi I dah delete model fitness tu. So itu it means something, right, to measure the fitness of the model, right? So this is a coefficient table. So coefficient table should be same as our table here. Dia sepatutnya dapat macam ni lah. But I tambah sikit confident interval, right? I tambah confident interval. So this is the newer version. Kalau newer version, kalau table significant tu very small, kalau kita tengok dekat sini, the older version dia indicate p value. This is a p value. P value dia letak 0.00. Dia bukan kosong sebab if you still remember dalam normal distribution, it is an asymptotic distribution kan, the tail is asymptotic, means that it will never touch zero. It will never touch zero. Maksudnya dia ada value dekat sini, very small value. So the new version present nicely and accurately, right? Less than 0.001. It should be presented less than 0.001. Right? Very small value. So basically overall, this is the same result as in our book. So dekat sini, the first part ni unstandardized coefficient. Kita akan tengok unstandardized coefficient. Jangan tengok standardized coefficient. Standardized coefficient does not report the intercept value. So since our syllabus, we are looking into y equal to a plus bx, right? So this is the constant. Constant will represent the value of a. H will represent the value of dekat sini. So, the regression equation dekat sini is y equal to 71.133 minus 0.409x. And we know that this is h and this is time. Okay? And if you can see here dekat sini, the p value here 0.002. Kita tak tengok p value dekat dekat coefficient, dekat constant, right? Kita tak tengok value p value dekat constant. We only look the p value at dekat value variable of independent variable. So the hypothesis here, we can say is that h having no relationship towards time. Null hypothesis sama je adalah kalau you nak guna yang atas tadi I buat tadi apa? This one. There are no correlation between age and time. There is a correlation between age and time. Benda yang sama je. Right? There are relationship between age and time. So since the p value is less than 0.05, we're going to accept null alternative hypothesis. So there is a relationship between age and time. Right? Okay? So now, dekat sini, benda yang sama lah. Dia kata prove that product Bowman correlation coefficient negative 0.01 negative 0.901. So you kena prove lah. So ni dekat atas ni result yang dia bagi dekat sini. So you kena prove dekat sini. Benda yang sama lah. So dia bagi data kan. So data ni dia bagi you boleh jawab lah. Benda yang senang saja. Actually okay. So basically example ni dia you need to calculate by yourself lah. Just want to confirm the result with the statistical table. Itu saja. Right? So example number 6, dan this one kita nampak kat sini, they give us the value of scatter diagram. You can see that the scatter diagram showing increasing trend from left to right. So this is a positive correlation. Right? So then they give us the value of the coefficient table, and they hide the value of V and W, right? So from the scatter diagram provide comment relationship, there is a positive correlation lah. There is a positive correlation. So then calculate correlation coefficient and interpret the value. So dekat sini dia tak bagi first table yang kita nak tu. So dia tak bagi, you need to calculate lah from this table, right? So from this table dia dah bagi kat sini. This is very clear cut. Kalau dia dah bagi scatter diagram, kita nampak dekat sini. This is Y. This is X. You should not make any mistake dekat sini lah. Ataupun you tengok dekat sini. This is X. Advertising cost. So you should not make any mistake here. Right? Sebab dia dah bagi clear cut. So dekat sini, you kena calculate correlation coefficient by the data, right? And then given that the regression line is 19.707. So dia dah bagi hint. Dia dah bagi result, jawapan dah. Right? So what are the value of V and what are the value of W? V adalah constant. So constant should be V should be 19.707. W is, this is W lah. Right? So interpret the slope of the regression. So interpret W. Right? Determine the coefficient of determination daripada tu, and then predict. Very simple. Right? So this is example number 7. Determine the R squared. W kat sini, R squared is dapat daripada square of R ni lah. You need to square R, dapat W. Right? So basically this is a very simple question. So I want you to answer all the question. Guys, sama juga. To answer all the question by today, right? It should be very easy. Sekejap saja you buat. Right? If you understand, you follow my lecture daripada awal, you boleh dapat, you boleh faham lah. Right, so you can do it by yourself. I think this is very simple as example lah. You can do it by yourself. You don't need my assistant anymore. So, any question before we end our session?
No, sir.
No, Alright. So I think that's all. Thank you very much. Assalamualaikum.